Chapter 29, Trigonometry. So you may have heard about this before. It's quite a famous topic. Lots of people always complain on TV shows and stuff about trig or trigonometry. But what we're doing should be quite straightforward, hopefully. It's the sort of beginning of trigonometry. It carries on through up to university and in lots of different subjects. If you do architecture or engineering, especially engineering, there's lots of it. Anything with graphs or any sort of planning or anything with or physics, obviously has a lot of it. Anyway, we'll go into what it is. Trigonometry is basically how the sides of a triangle, specifically a right angle triangle, how they relate to each other as the angle changes. So we have an angle here. If we make it bigger and keep the hypotenuse the same, remember this is called the hypotenuse. It's the side opposite the right angle. So if we make this angle bigger and we keep this the same, then we have it maybe like, oh, it's too big. About that. So it becomes like this. So I made this angle bigger. This is the same length. What can we say about this side? It's got much bigger. This side, it's got smaller. What if we make the angle smaller? So we'd have something like this. And this one's got smaller. This one's got bigger. Okay? So as we change the angle, the sides always relate to each other. If one gets bigger, the other gets smaller. If the other one gets smaller, then the other one gets bigger. Okay? So there's a relationship here, and it's all been worked out for you, and it's all sort of stored away in your calculator. So we'll get on to how to use it in a moment. Let's just look at if we make the hypotenuse bigger and smaller. So let's make it bigger, keep the angle the same. Then what happens to the other sides? They both get bigger. What if we make the hypotenuse smaller? What happens to the other sides? They both get smaller. Okay, I'm just sketching here, so obviously it's not super accurate, but you can get the idea. If you're making one of the sides bigger, the hypotenuse, then everything gets bigger if we're keeping the angle the same. If you're changing the angle, then one gets bigger, one gets smaller. Okay, if you're keeping the angle the same, then everything's growing with each other. We did an experiment, some of us, at the start of the year, where we divided certain sides by each other. And you can do this yourself if you wanted to. So what we did is we drew loads of right-angled triangles, and you make sure they all have the same angle. So let's say this is 50. You draw that one. You draw another one. This is 50. And you draw a massive one. This is 50. Make sure they're all right-angled. Make sure you've drawn them all correctly. And then you divide the sides by each other. So if you divide this one by this one, this one by this one, and this one by this one, and you should get the same number, roughly, for all of them. And you can do it any combinations of sides. So you can do, I did those two there. You could do this one and this one, or you could do like this one and this one. It's up to you. If you want to do that experiment, you'll find that they always divide the same number, and that's because of the size of the angle. If we change the size of the angle, we get different numbers, and like I said, they're all sort of stored on the calculator for you. So before we get into how we're going to use it, we need to know how to label a triangle properly for trig. So when we're doing this, we're always going to have went in the wrong order there. Let's label the triangle first. So we know the side opposite the right angle is the hypotenuse. Sometimes just written as hype for short, or just H if you're even lazier. And then we're going to have an angle here. And what we call the side that's next to the angle, that's this one, we call it the adjacent. Adjacent just means next to. If something's adjacent to it, it's next to it. Or if you're lazier, adj, or even lazier, a. And then this side, it's opposite the angle, so we call it the opposite. Or the op, or o. Okay, so we've got three sides, we've got our right angle, we've got another angle. For all these questions, we're always going to have the right angle, so I'm going to sort of ignore that. But we're going to have one angle, so that's this one I'm talking about, because I'm ignoring the right angle, and two sides. And we're going to be missing out one of these things. So we're either missing the angle, and we've got two sides, or we're missing one of the sides, we've got one angle on the side. One angle, yeah, on the side. And we use the two things we have to find out the other thing. Okay. Just before we move on, we need to be careful. Here's another triangle. The angle's up here this time. This stays as the hypotenuse. But now this side is adjacent because it's next to the angle. So this is the adjacent and this is the opposite. So just be careful where that angle is, which one's opposite it, which one's next to it. Okay. So, and let's do one more, just so you can see. Here's another one. Here's the angle. So this is the adjacent, this is the opposite, and this is the hype. Because it's next to it. So just be careful when you layer them. You'll get used to it, hopefully quite quickly. So, what we're going to do, we're going to use this thing called SOHCAHTOA. You might have heard it before. SOHCAHTOA. Now, it doesn't really make much sense. It's a way for us to remember three formulas. So however you can, remember this SOHCAHTOA. SOHCAHTOA. You can repeat it over and over again. It's kind of a funny word, so maybe it sticks in your head. You might have heard it before. Lots of people talk about it. So three formulas. What are they? Well, SOHCAHTOA. It's kind of split into three parts. So SO. What does SO mean? Well, S stands for sine of x. And let me draw a right angle triangle here so we can remember. So we'll have this right angle. We had hype, opposite, adjacent. So sine of x is the opposite over the hypotenuse. That's sine, opposite, hypotenuse. So it's the first one is opposite over hypotenuse. Then K, maybe you can guess what this is. Cos of x is the adjacent over the hypotenuse. So A over H. The last one, TOA, tan of x is the opposite over the adjacent. Okay, so we have our three things. You need to memorize SOHCAHTOA, and then you can get all these from SOHCAHTOA quite easily. And this is what I was talking about, where we divide one side by the other. So this would give us our number for tan. If we did opposite and hypotenuse, we'd be getting sine. So it's just how the sides relate to each other when we divide them. Okay, that's all it is. And now we've got these formulas, it should be pretty easy to work out. Okay, so let's have a look at an example. Here's one. So we're missing one side, we have one side, and we have one angle. So we've got two of the three things. And of course we know this is the right angle, sorry. So first we're going to label the sides. This is hype, this is adjacent, this is opposite. Because remember it's opposite. So just be careful when you're labeling it. We're fine now though. So what do we have? We have the angle, we have the hypotenuse, and we need to find the opposite. We're ignoring the adjacent because we have no information about it. So we have these two. So which one are we going to use? We're going to use SO. Oh yeah, it's got O and H. K, let's check the others. TOA. Which one has O and H? SO. This one doesn't and this one doesn't. So we can ignore them. We're just going to use SO. Hopefully you can remember it already, what it means. It means sine of x goes up over hype, opposite over hypotenuse. So now let's just put the numbers in. So sine of the angle, 30, is the opposite, which is x, divided by 7. And that's it. That's our formula. Let's rearrange it slightly by putting the 7 over here. So we get 7 sine 30. You could put times, but we tend to use sine and cos and tan like the algebra almost, so we don't put the times there. So 7 sine 30 equals x. Get your calculator, make sure it's in degrees mode, It should have a little D lit up at the top, and then you can press 7 sine 30. Type it in. I got 3.5. Remember, in Portuguese, it's sen. So you might have to press that button instead of sin. Yeah, and that's it. You just type it in the calculator, and should be pretty straightforward. I can't tell you all how to fix your calculator if it's not in degrees. We'll have to go through that on Zoom. But this is basically, if you're in the right setting, you should just get 3.5. Should be pretty easy. Let's look at another one. Here we go. Quickly, let's label them. H. This one's A because it's next to the angle. This one's O. So we want A and we want O. We're not using this one at all. So which one had A and O? It only has O, it doesn't have A. Only has A, doesn't have O. Yeah, A and O, perfect. So let's make the equation. Tan x equals O over A. So tan 43 is 6 over x. Just getting the numbers from the diagram, putting them in. Now a bit of rearranging, going to move this up here, so we get x tan 43, 6, then divide by this. And what do you think we do? We just stick it in the calculator. So we get 6 over tan 43, 6.434. Okay, that's it. Should be straightforward enough. Go back and watch it again, maybe. I'm going quite fast. Let's do another one. So this time we have H. This is the adjacent, this is the opposite. We don't need this, we need H and A. So nope. Sorry, K. Oh, H and A and H. Yep. Nope. So it's this one. Cos, I'm just going to put the numbers in straight away. Cos of 50 is the adjacent divided by the hypotenuse. So you should probably write out the formula first. I'm just rushing because I don't want the video to be too long. Bring this over. 10 cos 50 cos x. Put it in your calculator. 6.428. I rounded that. Okay. There you go. That's your answer. That's the length of the side. That's what we've worked out, what this x is. So we're saying this is 6.428. Okay, so far we've only done lengths of sides. I'm going to show you one with a missing angle now. I forgot to do an example for this, but let's just do it. So here's a right angle triangle. Let's say this is 10, this is 8. We want to know this one. Then again, we just label H, this is opposite, this is adjacent. We're looking at H and A. So this is where we've got two sides, we want to find the angle. H and A. So that's cos again, H and A. So cos of x equals A over H. So cos, yeah, this should be x, sorry. Cos of x equals 8/10. Now, yeah, it's a good thing I did this, because this, how do we get rid of this cos now? Well, what we do is we do something called inverse cos. And all that is on your calculator is you pressed shift cos. On the Portuguese ones, I think it's arc cos. But sometimes you'll see it with this cos to the -1 is what it's normally in. Definitely in Britain, that's what it's normally known as. I guess it's arc cos, arc tan, arc sen for Portuguese. But here, just press shift cos, and then put in 8/10, and you get 36.860, rounding it. Oops. So I'm going to round it 3 decimal places. So it was 36.8698 . So 36.870. Okay, and that's the angle there. So again, it's just using the formula. We have to use this inverse thing. So I'll show you another one. Hopefully this is the last one. Let's say this is, let's go for 9. This should give us now hopefully nice easy numbers. And this is 12. And let's say we want this one. So this is H. This is next to it, so it's A. This is opposite it, so it's O. I'm going to write it there because it makes it look like 90. O. So we're wanting A and O. It's TOA. So tan of X, so that should be X, equals 9 over 12. Okay. So we just do X is arctan or inverse tan. Inverse tan is what you usually call it. So X equals shift tan on your calculator of 9/12. And we get 36.8. Oh, the same number. That's because so this would be 6, 8, and 10. This is 9, 12. Okay, sorry, I randomly chose numbers there. But we got the same one anyway, because it's just the same triangle, but just a bit bigger. Sorry if that's confusing. But you can see we just got the same value, 36.870 degrees. Okay, so if you've got any questions, put them in the comments. That's sort of a brief overview of trig. Hopefully, if you can learn SOHCAHTOA, it should become hopefully straightforward. And then there's a few more things for trig at the end of the chapter, but this is sort of the basics. Yeah, good luck.